In problem number 11, you're given some real-time data and the numbers that actually represent something. So as you can see, I copied the table down here because it was too hard to go back and forth at the top of the paper over here. So the table shows the number of hours you studied before your 8 math tests and then your percentage score on each of those math tests. And so what we want to realize here is that number one, again, our goal is to come up with the equation of a trend line, and we're given the number of hours, and one thing you always want to ask yourself is what is the independent variable and what is the dependent variable? Well, the independent variable is the one that the other data depends on. So in other words, you could ask yourself, does the number of hours depend on your score, or did your score reflect or depend on the number of hours that you studied? Well, which comes first? Well, the number of hours you studied comes first, your score comes after, and so the number of hours that you study, that's your independent variable. And then your score, which depends on the number of hours that you studied, would be your dependent variable. So the independent variable, we usually use X to represent that, and we usually let Y represent our dependent variable, and we know that when there's an X and a Y axis, the X is the horizontal axis, the independent variable is always the horizontal axis, and the dependent variable is always the vertical axis. So X represents the number of hours, and so we can label our units of measure here, and the score as a percentage, and that's what it says, right? Yeah, the score is a percentage of 100, so a typical score would be. Now, when we mark off our independent variable axis, so you want to look, what's the largest number you have here? And we have 14 as our largest number, 14 hours to study for that test. So let's go ahead and mark it off and by fives, 5, 10, 15. So if we go 5, 10, 15, then we have, that's our horizontal axis, but then our vertical axis, don't start marking off 5, 10, 15, because we have to go all the way up to 95. So let's make sure we can get 100 in there. Let's put 100 up there. 50 will be right there. And then, so we go 1, 2, 3, 4, 5. So 10, we're going to move up by 10s. 60, 70, 80, 90, 100. So each of these are 10s. And so we can go through 50, and we can put a 100 up there. We can also mark off our axes, horizontal axis here. 1, 2, 3, 4. Just got to be careful. 1, 2, 3, 4. 1, 2, 3, 4. So if we want to, we can write it down like this. We can label each of the numbers. It gets a little tight in there. And I'm going to go ahead and leave the vertical axis alone right now. Now let's go ahead and plot the points here. If we studied 8 hours, then we got a 75. So 8 hours, and we go up to 60, 75 would be right about there. Just like the last two problems, this does not have to be exact. You just want to get close and make it look fairly accurate. When we studied 5 hours, we got a 62, so that's right about there. When we studied 12 hours, we got an 80. 12 hours, we got an 80, right about there. And we just keep going. 10 hours, we got an 85. 10 hours, we got an 85. 2 hours, we got a 35. 9 hours, we got a 70, right about there. 11 hours, we got an 82. 60, 70, 82, right about there. And 14 hours, we got a 95. So 14 hours, we got a 95. So that was our last test, and we needed to get a good score there. So there you go. So you can see the trend of the data, which probably should come as no surprise, is that the more you study, the higher your grades are going to be. So that's the point of this, is that we've got a trend, and it's a linear trend. So, or at least we're trying to come up with a linear model for this, and so if we draw a line, again calling it a trend line, we're going to try to come up with the equation of that trend line. So my first two examples, I hit the y-axis at a really good spot. This one I'm a little bit under, 10, 20, 30, 40. 40 is probably actually more like right there, so we're going to call that a 38. So we're going to call the y-intercept equals a 38. And then from there, guys, we just need to come up with a slope. And so again, slope is rise over run. And, well, there's no great way to do this, but all you have to do, though, is just decide on a point on the line. Let's just go ahead and use this y-intercept. And from that point, we decide, okay, we're going to go up a certain number and over a certain number. So if we call that 38, that means our change in y, we're going to go up 12, and we're going to go over how many? Well, let's find another point there. Well, what is that? If we go up 12 and over 1, 2, 3, 4, let's call that up over 4. Up 12 and over 4. So that's our estimate for the slope. So therefore, the slope is about up 12 and over 4, which is equal to 3. So therefore, we, again, if we want to come up with the equation of a line, we either need a point in the slope or the y-intercept in a slope. So we always have to get the slope, and we always have to get a point, or slope and the y-intercept. Well, here we have our y-intercept. So our equation of our line is y equals the slope times x plus our y-intercept, and we have the trend line equation. That's it.